Is this recording? We'll find out if it's recording. All right, we are starting our next little mini unit on rationals. So rational numbers are just anything that can be placed or written as a fraction. So the little cartoon at the front, when it says like get real, it's saying it to I. What kind of number is I? An imaginary number. I is then saying be rational. Does pi ever turn into a decimal that can be written as a fraction? No. So when we look at rationals, what we're really going back to are fractions. So rationals just can be written as a fraction. A rational expression then just means fractions with numbers and variables. And then the key part about this is we are going to have no equal signs. Once you introduce an equal sign, it's going to turn into an equation, not an expression. So kind of the same thing we did with complex numbers. We are going to go through simplifying, multiplying, dividing, adding, and subtracting rational expressions. Most of the stuff you guys learned in middle school, we're just going to kind of step it up one level. And now we're going to be looking at expressions with variables in it rather than just like how do you reduce a common fraction. Monomial means you're going to have one piece. So when you say like, oh, it's a monomial, it just means there's no plus or minus signs here. When you guys reduce fractions, you always look for what it can divide. So just looking at it, what number divides both 8 and 12? 4. So technically what you're doing is you're saying 8 is 4 times what number? 2. And then there's an x on top. 12 is 4 times what number? 3. And there's an x on top. And when you simplify it out, when you divide that 4, what you're really saying is within a fraction, if there's a 4 on top and a 4 on bottom, what's 4 divided by 4? 1. So if you have the same thing on top and bottom of a fraction, they cancel out because they divide to a 1, and ones don't do anything in terms of like multiplication and division. Same thing goes for the x. If you have an x on top and an x on the bottom, they're going to cancel. So the only thing that's going to be left over is 2/3. So technically when you're like oh, you divide by 4, you're really just canceling those 4s out. Binomials means now you're going to have things that are factored, I guess. So a binomial like x plus 2 has 2 pieces. As long as it is a whole chunk, you can reduce. So on top and bottom, these both have an x plus 2. So you can cancel out that whole chunk together because x plus 2 divided by x plus 2 is all going to reduce to a 1, and you're just going to be left with x minus 5. The one thing you can't do is if you have adding or subtracting, it can't reduce with something that doesn't have adding and subtracting. So this right here cannot be reduced even though they both have a 6 with it. X plus 6 is a different quantity than just 6. So you can't cancel these 6's because of the plus sign in the middle. This is one whole chunk. The x and the 6 are not separate. It's one thing. And if you think about it as like, if x equals 1, you would have a 7 on top and a 6 on the bottom, and they wouldn't cancel. So x plus 6 is a whole chunk that can only be reduced with another whole chunk. Questions on that? All right, simplifying fractions that are rationals is really just going back to exponent rules and fraction rules. The one thing that's kind of weird about these, we haven't done exponent rules yet. So as I'm going through these, it's going to be a little bit of a pre-look to what we do in like February. Key part, if you have the same thing on top and bottom of a denominator, they are going to cancel. So first one I'm going to do the long way just so that you guys can see it. Numbers are going to reduce with other numbers. What number would divide both 6 and 14? 2. So I'm going to take a step and just write 2 times 3 is the 6. 2 times what number is the 14? 7. X to the third on top means how many x's are on top? X squared on the bottom means how many x's are on the bottom? 2. So once you have it written into all of the little pieces, if it's the same thing on top and bottom, they cancel. So the 2's are going to cancel. 1x can cancel with 1x. One x can cancel with one x. So after you go through and do all the canceling, what's left up top? What's left on the bottom? So numbers reduce like you're used to reducing with numbers. If you look at the variables, we had an x to the third on top and an x squared on the bottom, and we ended up with a single x. What happened to our exponents? Like, what operation happened to our exponents to change to a single x? Did they add, subtract, multiply, or divide? They subtracted. So make a little note, probably over here. Subtract your exponents. And then, do you see how like x to the third is on top? If the bigger number is on top, they're going to end up being on top. If the bigger number is on bottom, they're going to end up being on the bottom. So since the 3 was bigger and that was on top, that's why they ended up being on top. Next one. This is already factored for you. So when it's already factored for you, you just have to look for chunks that are the same. So what's a chunk that they both have on top and on bottom?
X plus 1.
X plus 1, so those cancel. Can you reduce those x's? No, the one on the bottom is attached to the 3, so it could only cancel with another x plus 3. So our final answer is we're left with an x on top, we're left with an x plus 3 on the bottom. The way that these are going to get tricky is in the third example, that denominator isn't factored. So in order to be able to start canceling things, you need to have them in their multiplication pieces. So you need to make sure everything is factored. 4, not going to factor that. In the denominator, how would you factor x squared plus 2x? Yeah, what's our GCF here? What's left over? So make sure everything is factored. Do we have anything that is the exact same on top and bottom? Can we reduce the 4 and the 2? No, because what is that 2 attached to? An x. So one thing to keep in mind, if nothing is going to cancel, your guys' answers should look like the pieces, not the beginning. So that is one thing that I want to make sure you guys are aware of. Not all fractions can be reduced. If you have a fraction that can't be reduced, I still want you to break it up into the pieces so that you can see this is how things work out. Go to the bottom of this little column or whatever. This right here, put a big star, because if there's going to be something that you miss, it's probably going to have to deal with this. X minus 4 is already factored. And the bottom, do you see how it's backwards of what it normally is? So if you were to reverse this and write it the normal way, is our x value positive or negative?
Negative.
Is the 4 positive or negative?
Positive.
Are these two the exact same? No. However, on the bottom, if we take out a negative 1, what's that negative x going to turn into? Positive x. What's the positive 4 going to turn into? So you are allowed to reverse the order. You probably should, because we're used to seeing our x's in our number. With that negative 1 factored out, do you see how they both have an x minus 4? Technically, we have a 1 on top and a negative 1 on the bottom. If nothing is left over, there's always a 1 there. What's 1 divided by negative 1? Negative 1. So if you ever have this setup where you have a minus, it has to be with a minus, and they're backwards of each other, it always reduces to a negative 1. So if you have this setup where they're the same, but they're backwards and you're subtracting, it'll reduce to a negative 1. That's helpful for number 4. Can we factor the numerator at all? Nope. The denominator. 16 minus x squared. How would this one get factored? Where does the 16 come from?
4.
How do you get minus x squared with nothing in the middle?
Plus x minus.
Yeah, plus x minus x. So difference of perfect squares, just follow the order you're given. Which two are really close to being used?
X minus 4, 4 minus
Yes.
x.
These two. They don't straight cancel to nothing. whenever you have this set up where they're backwards of each other with a minus sign in the middle, these are always going to reduce down to -1. Because technically you would factor out a -1 in the bottom, and then you could cancel them out, the -1 would be left over. So final answer of this, we have a -1 up top, and we still have our 4 plus x on the bottom. So be careful, if you have opposites, they can reduce, but it's gonna leave a negative sign behind. Okay, next one. When you're given something that's not factored, make sure you factor first. You just can't start crossing off like x squared with x squared. As soon as you see a plus or minus sign, it needs to be factored. Numerator wise, do we have a greatest common factor? Nope, so we go x and x. What do we know about our signs if we have a minus sign at the end? Are they the same or opposite?
Opposite.
Opposite. How do we multiply to a -3 and then also get a -2? 3 and 1, which one needs to be negative?
3.
The 3. So factoring is forever going to be around. Denominator wise, do we have a greatest common factor?
No.
Nope. So 2 parentheses, x and x. How do you get a -6 with a -1 in the middle? Yeah, -3 plus 2. Once it is factored, if you have the same thing above and below, they're going to cancel. Do we have anything that's going to cancel here? Your x minus 3's. So what's left over up top? What's left over on the bottom? Yeah, you can't cancel those x's because they're both attached to other numbers. So again, once you start factoring, it has to be a whole chunk for a whole chunk. Questions on that one? All right, next one. Can we start canceling or do we have to factor it first? Factor it first. So on 2x squared minus 72, how would that one begin? Factor out what? 2. So there is a greatest common factor, so we can take our 2 out. We'll have an x squared, 36, or 72 divided by 2 is 36. Can we factor that anymore? Yeah, x squared minus 36, they're both perfect squares. So our top is a 2. X squared comes from x and x. How do you get minus 36 with nothing in the middle?
Plus minus 6.
Yeah, plus 6 minus 6. Bottom wise, do we have a greatest common factor? What can we take out to begin?
4.
4. So x squared minus 2x, is it 24?
Yeah.
Okay. So when you guys are doing your factoring, it might take a couple different steps, so just make sure you factor it all the way down. We can factor x squared minus 2x minus 24 more. We still have our 4 in front. X squared is x and x. Do we have same signs or opposite signs? How do we get a 24 and a 2?
Minus 6 plus 4.
Yep, minus 6 plus 4. So make sure everything is fully factored first, because once you have everything fully factored, you're really just canceling things out. What's something that's going to completely cancel out?
Minus 6 and minus 6.
X minus 6, x minus 6. The other parentheses don't cancel out. Numbers still act like numbers. So in the front, we have 2 and 4. What number divides both 2 and 4?
2.
2. So you can still reduce numbers in the front just like you would always reduce in a fraction. So 2 divided by 2 leaves us with a 1. We still have x plus 6. On the bottom, what's that 4 going to turn into when we divide it? A 2. And then we still have that x plus 4. So numbers in front. So if you just have a straight up number that's hanging out in front, you still can reduce your numbers just by dividing them both by the same number. So when you simplify fractions that have variables in it, just make sure you factor, and then it's a 1 for 1. Do you guys have any questions on this? All right, assignment.